So when we left off at our last video, we discussed the fact that we were able to create a periodic table that was going to assist us in determining a quantum number. And a quantum number, again, is just an address that tells us the approximate placement of the last electron of a specific atom. So that consists of four different parts. The first one is the principal quantum number that tells us the energy level. We denote that with the letter N. The next one is the angular momentum, which is denoted with the letter L. Then we have the magnetic quantum number, which is M, that tells us the kind of spatial orientation. We talked about X, Y, and Z axis, so the 3 dimensions that it exists in. And then the last one was a spin, either clockwise or counterclockwise, and that's denoted with the letter S. So we're going to use our periodic table that we created in the last video to help us with that. So let's say that we're starting with hydrogen here, and we want to know its number. So we're going to find hydrogen. Hydrogen's located right here on our periodic table. And we see that for the first part of our quantum number, it's going to start with N, and for the S block elements, those all have whatever the period it is that it's in. So for hydrogen, that's going to be a 1. Then the the orbital shape is 0. That tells us that it is going to have a spherical shape. M is going to be the spatial orientation. So for hydrogen, that's going to be a 0. And then the S is going to be a positive because it's in this column. So when you get done, it should look like this. So the quantum number for hydrogen is 100 plus. If we move on to helium, we can do helium. It's done the same way. Period is 1, L is 0, 0, but this time it's a negative. So that's what distinguishes hydrogen from helium. We can skip over. We can do lithium next. So lithium is found right here. Now the period for this one is a 2 because it is in this row. So it's 200 plus. 2 for the period, 00 plus because lithium's right there. The next one we're going to do is beryllium. So beryllium is found over, you could do beryllium, that's done there. You can see what you came up with for that one. And then we're going to do boron next. So boron's over here. So boron's going to be, period is going to be 2 because it's in the second row here. 1 because it has a p orbital. That tells us that it has a peanut shape. -1 plus. So there is the quantum number for boron. So when you do boron, that's what it should look like. All right, the next one that we're going to do then is pause the video and check to see if you can do the next few on your own. All right, so you've had a chance to do those. Here are the correct answers for those. Now, the next one we're going to do is another S block orbital. So that is calcium. Calcium is in the 4th period. So that's going to be 4. Then it's going to be a 00 minus because it's right here. So that's how calcium should look. Then, if we skip over to iodine, iodine is over here, so if we follow our periodic table over it, it's kind of off the screen, so you have to do that on your periodic table. But you'll see that it's in the 5th row, so 1, 2, 3, 4, 5, if you would like. So we're going to do that. 5, 1, because that's the shape. 0, because that's in that column, and a minus. Neptunium is down here. I put a little NP there to help you with that one. So here, period is -2. Our N is period -2, so that's 7 minus 2 is 5. Our shape of our orbital is an F orbital, so we're going to give it a 3 to tell folks that that's the shape of it. Then N has a 1 here, MP does, and then a plus in its box, so that is the last part of its quantum number. Mercury is down here, so it's going to have period -1, so that's going to be 5. Then we follow up here, it has a D shape, so it's a 2, 2 minus for Mercury. And you can pause the video, work on the next ones yourself, and then you can check your answers. Thank you.